Welcome to another video. This is another epsilon-delta proof for limits. We've got this limit, and I want you to compare it to this limit. As you can see, the only things we don't know, well, we don't know many things. Here, f of x will be the same thing as this rational function. A is going to be 3 in this case, and L is going to be -1 in this case. What this means is that we want to show that this -1 is this limit. I know you can compute the limit, but we want to prove that it is the limit using the epsilon-delta definition. Okay, now what do we need to show? We need to show that for every epsilon greater than 0, it has to be positive because distance is always positive. That's why. There exists a delta greater than 0 such that if the absolute value of x minus a, x minus this number, if you move away from 3 a little, that's it. Once you move away from a and what you have is less than delta, then this is true. The distance of the function from the limit is less than epsilon. That's the general definition. So what I'm going to do first is try to translate this from this language into this language. We'll see what we're going to show, and from there we're going to do the whole proof. Let's get into the video. The first thing I'm going to do is to translate this statement of the proof to reflect what we have. So what we're going to say is, for all epsilon greater than 0, there exists a delta greater than 0, such that 0 less than the absolute value of x minus, this is my a, 3, less than delta implies that the function, what is the function? The absolute value of the function, x minus 7 over x plus 1 minus -1. I'm going to write it as -1, like that, is less than epsilon. This is the statement, let's put this in parentheses. This is the statement translated from here to here. And all we're going to do from now on will just be from this statement. This is beautiful. Like I said in other videos on epsilon-delta proofs, your focus should always be on this. See this statement? That's the key to everything you're doing. You want to make sure you can get x minus 3. And you're going to start from this side. So you're going to say, if I'm talking about this, then I want to be able to find a delta. Remember, the mission is for all epsilon greater than 0, there exists a delta. We just want to show that there exists a delta. If we can find a delta, we're done. So how do you start this proof? I wish I could start here, but I might have to come back to it. I actually want to start from here so I can save space. So let's begin. So remember, always start from here to find your delta. So you're going to say that I have x minus 7 over x plus 1 here. Now this is minus minus is going to become plus 1 is less than epsilon. But you know, this is the same thing as if I try to make this a single fraction, what would I get? I am going to have x minus 7 plus x plus 1 over x plus 1 is less than epsilon. Do you see what I did? So you make the two into a single fraction. Now, what does the top give us? X plus x is 2x, minus 7 plus 1 is minus 6. So we have 2x minus 6 over x plus 1. Okay, And what does this imply? This basically implies, remember also, I told you to focus on this. Can we get x minus 3 anywhere here? Yeah, it looks like it on top in the numerator. So what I'm going to do is, I'm going to say this implies the absolute value of 2 times x minus 3 over x plus 1 is less than epsilon. The product of 2 over x plus 1 and x minus 3 is less than epsilon. I'm just trying to isolate this guy. 2 over x plus 1, put it in absolute value, and put this also in absolute value, x minus 3 is less than epsilon. The absolute value of a product is the product of the absolute values. You don't need to worry about that, okay? We don't have the triangle inequality problem here because we don't have plus between them, we have multiplication. So you can split them this way. Now, this is the guy we've been looking for. If this was a number, we will just divide both sides by this number, and then we say this is less than delta, and we call this delta. But what we have here is not a number, it's not a constant, it depends on x, but we don't want it to depend on x. So what can we do? Now, let's go back to the basis of limits. Remember, when you say the limit as x approaches a point is something, you're very close to that point, right? You're very close to the point. So what we're going to say is, let's go investigate a point that is very close to 3. How far can you go away from 3 that you say, okay, I'm not too far? Well, if you go more than 1 unit, it is logical to say you've gone too far. So it's better to stay within 1 unit away from 3. Now, when we say 1 unit, it does not mean 1 million. It does not mean 1. Because if the unit on the x-axis is in microseconds, 1 is not 1, it means 1 microsecond. So don't worry about what the 1 is. It just makes our computation easy. And by the way, we choose the smaller, not always 1. So see what happens. Consider a point 1 unit from 3, okay? We're saying x minus 3 is within 1 unit. A point within 1 unit from 3, okay? A distance within 1 unit. Maybe I should rewrite it. Consider a distance within a unit from 3. Okay, let's put it that way. So remember, absolute value means distance from. Okay, so here we can rewrite this inequality and say that we have -1 is less than x minus 3 and it's less than 1. Okay, this is what we have. The reason we're doing this is because we're trying to be as close to 3 as possible. Remember, 3 is the target point and we don't want to go beyond 1 unit. Okay, so just to be reasonable, you can choose any number, but it won't make sense. You can be closer. Okay, now, and 1 is easy to work with. This is not my focus. My focus is to replace this guy. Remember, this guy depends on x. I don't want it to depend on x. I want it to be a number. So what I'm going to do is, I want to make this middle to look like this so I can replace this with actually numbers. So what can I do to x minus 3 to make it x? Forget about the 2 on top, okay? We're going to come back to that. What can I do to x minus 3 to make it x plus 1? I need to add 4 to this. Yes. So if I add 4 plus 4, I have to add 4, add 4. So what I have left is, I have 3 is less than x plus 1 and x plus 1 is less than 5. So now I've gotten 2 candidates to go replace this guy. The question I want to ask myself is, which of these 2 guys is good for the proof that I'm doing? Should I pick 3 or should I pick 5? You tell me. Now, this explanation, do not get lost. Because what I'm about to explain to you, if you don't get it, then you'll just get lost. So don't get lost. Now listen to this. assuming I tell you that x is less than y, and I say that I'm going to replace this x with 4. And I say 4 is less than y. If this is true, then you know that y must be 4 point something or 5 or 6, any number bigger than 4, right? If this is true. Then if this is true, and I've already told you that x is less than 4, would you have any doubts about the first inequality I wrote before? If I tell you that x is less than y, I'm just claiming it, and then I come here and I tell you 4 is less than y, okay? And then you have seen before that x is less than 4. If x is less than 4 and 4 is less than y, then clearly x is less than y. That's the exact thing we're going to do here. I'm telling you that this is less than epsilon. What I can do is make this bigger, like I made this bigger, because I told you x is less than 4, so 4 is bigger than x. I want to make this bigger and still say it is less than epsilon. Because if this is bigger and it's less than epsilon, it means that the smaller one was less than epsilon. So how can we make this bigger? I want to make this bigger. How do you make a fraction bigger? You make the numerator bigger, or you make the denominator smaller. Remember that. Make the denominator smaller or make the numerator bigger. That's how you make a fraction bigger. So I want to keep this, but I want this to be bigger. In order to make this bigger, this is a constant, this is a constant. The only thing that I can worry about is the x, and that's why I said I'm going to make x plus 1. So the denominator will be made smaller so that this becomes bigger. So instead of picking this, I'm going to pick the smaller thing. I know because it's a fraction, it sounds counterintuitive, but that's the essence of it. I'm trying to make this bigger, make it bigger than x, so that if it is true, then it means the original was also true. So I'm going to replace this x plus 1 with just 3. So this is going to be 2 over 3, not 2 over 5. Okay, I hope I didn't lose you. Leave a comment in the comment section. This is what you always do whenever you have two terms and you're trying to find what your delta is. So from here, I am going to replace this, like I said, so that I have, this implies that 2 over 3 of absolute value of x minus 3 is less than epsilon. Okay, now I don't need the absolute value bars because it's positive, so I can always take this out. Okay, let's take this out. And now I can divide both sides by 2/3 so that I know that, let's write it here, absolute value of x minus 3 is less than 3 epsilon over 2. If we really know what epsilon is, we can say, okay, we have found our delta, but we're not sure. We want delta to be very small as possible. Remember, we don't want to go too far from 3. So despite the fact that we said x minus 3 is less than 1 in our assumption, this calculation we did here may have pushed this value beyond 1. We want it to still be small and small. So what we're going to assume is this guy is smaller than 1. If this guy is not smaller than 1, then we have to choose 1. We just have to choose the smaller one. Therefore, we're going to say our delta is the minimum of 1 and 3 epsilon over 2. Whichever is smaller of this, usually this is smaller than 1. Usually. But if it's not, then we just pick 1. Okay, so let's finish this proof. Normally, when you get to this point, I would say once you found a delta, your proof is okay. Some professors accept that, but some want you to show that the delta you're claiming works. Now we have two options. The first option is 1 and the other option is 3 epsilon over 2, but it has to be the minimum. So if we're choosing 1, it means 1 is less than this. So we can start with that and say, let 1 be less than 3 epsilon over 2. From here, you can see that 2/3 is less than epsilon. This implies 2 over 3 is less than epsilon. Just multiply both sides by 2 and divide by 3. You're going to have this. So now this is the key. This is the key. So remember that from the claim, we're saying if x minus 3 is less than delta, it implies that this is less than epsilon. But what we want to do is show that this is less than epsilon. But what really is this? So we're claiming this now. So if x minus 3 is less than delta, then this is less than epsilon. So what is our delta? We're claiming delta is 1, right? So let's say that absolute value of x minus 3 being less than 1 implies that this is less than epsilon. But what exactly is this? We already claimed that if we process this, see, that's what we did from here. If we process this all the way, we're going to end up here, right? And from here, we were able to show this. So we can as well write this expression and say this implies that 2/3 of x minus 3 is equal to, will it be equal? Will be less than, actually, will be less than. What would it be less than? Oh, if this is less than 1, then anything you use to multiply this will be less than itself. If you use this to multiply anything less, like 4 times a number less than 1, will just reduce 4. So because this is less than 1, this product is less than 2/3 automatically. And if this is less than 2/3, it is automatically less than epsilon. Why? Because we said 2/3 is less than epsilon from here. That's it. That's if you choose 1. So to prove 1 is always easy. Just say that it is less than the other one, and by the time you do 2, 3 lines, you're already there. So this is done. If our minimum is 1. If the minimum is not 1, then you go here, it's going to be the same story. So the second option is to suppose that 3 epsilon over 2 is less than 1. Okay, if 3 epsilon is less than 1, then we have to go back and do the same thing. We're going to say that the absolute value of x minus 3 is less than, what did we say is 3 epsilon? 3 epsilon over 2. So from here, what we have to do is go back again. Remember what it implies. Once you know what your delta is, this implies that this is less than epsilon. And we have shown that you can work your way all the way to this point. We're coming back here again. And that gives us this. 2/3 of x minus 3 is less than epsilon, but we want to show that this is really true. So what we'll say is we're going to multiply this by 2/3. Okay? This implies if I multiply this by 2/3, 2 over 3, absolute value of x minus 3 must be less than 2 over 3 of 3 epsilon over 2. Uh-oh. Did you see that? This cancels this cancels this. So what you have on the right-hand side is epsilon. Now, I can't write less than here. This is equal to, this is simplified into epsilon. And that's the end of your proof. Like I said, once you've gotten your delta, that's the hard part. Once you got this, you can always simplify back. You don't need to start and show all the work because it's the same work you're going to do. Just stop here before you do your final separation and then use it to do the final proof. So whether you choose 1 or you choose the other epsilon term, it's the same thing. You're going to end up being able to prove it as long as you pick the minimum of 1 and 3 epsilon over 2. I hope this helps. Leave a comment in the comment section. Never stop learning, because those who stop learning, stop living. Bye-bye.